So my name is Frank Berry. I'm with IT Brand Pulse, and I'm here to introduce your next speaker. He comes from a company which is a tough competitor, and they're also a technology powerhouse. In fact, they've made a couple of major announcements in just a couple of weeks. I'm sure he's going to talk about it. And your speaker himself, he is a tough mudder. And this is really a really relevant topic to the industry, and he's going to tell you about what that means. So join me in welcoming your next speaker, Derek Dicker. He's Vice President and Business Unit Manager with Microsemi.
Thanks, man. Don't want to forget that one. So thank you for your time. The one thing that Frank and I were talking about in terms of relevance of personal things that I do and Tough Mudder was the fact that this event is built around getting together as a community and overcoming obstacles. There's no time associated with an individual. It's actually built so that a bunch of people can get together and go have fun and knock down barriers and get to the end. And it's not unlike what we think is being done in the NVMe space. And I'm going to talk a little bit about that throughout the discussion. But before I do that, I wanted to address the one question that I get almost from everybody that I meet who's slightly outside of our industry. And that's, who is Microsemi? Now see, you guys don't know either. That's great. So I'm glad I threw this in. So the company was actually founded in 1959. It was incorporated in 1960. And it's one of the oldest semiconductor vendors in the industry that's left standing. And there aren't that many left of us, as several of you know. The headquarters is in Southern California in a beautiful place called Aliso Viejo. But we have facilities all around the world. There's just shy of 5,000 people in the company now. And about $1.7 billion in revenue forecasted for the close of our fiscal year, which is closing at the end of September. From an end market focus perspective, if you had heard of Microsemi, you would have thought of aerospace and defense in its earliest lineage, specifically around discrete products. But over time, they've taken on a strategy of serial acquisition and expansion into other markets. Communications was the first one. You may have heard of the acquisition of the assets from Vitesse. But also, most recently on September 15th, they closed an acquisition of PMC Sierra and added storage capability to the product lines. Now, the tagline that you see here on the right of the slide, "We put technology to work for people," is actually something that they live by. And I thought I would include just a few examples so you have a general idea of where the company plays and how they actually decide what products they're going to build. So by show of hands, even though I can barely see you with the bright lights in the back, how many people flew here to this event on a plane? Yeah, that's quite a few. And international, hold on, keep your hands up, I'm not done yet. International flights over a long, long pond. Awesome. So welcome. If you flew here on an international flight, there's a high degree of likelihood that Microsemi technology actually helped you get here. This is a picture of the Airbus A380. I had no idea that this was the case, but there are in excess of 1,000 FPGAs and 1,000 Microsemi FPGAs in an A380, and it's responsible for things like the flight computers, engine controls, all of the fully redundant system that's established there. Now, for those of you who are going, well, you're not in the Dreamliner. Good news is we're in the Dreamliner too. So the company actually has built itself upon creating high reliability solutions that address needs in spaces like avionics and others. Now, this may be a picture you've seen before. I had one of these phones on my desk not too distant in the past. We actually also have technology around power over Ethernet. We were a co-inventor of that technology, and today we're a market leader. And then also one that people don't really think about all that often. You pull a cell phone out of your pocket, you go make a call. That network needs to be synchronized in timing. And we sell a whole series of solutions into the timing space, and we're very fortunate that with the business that we built, we're a world leader in precise timing solutions. We have more than 50%. You can see 60% listed here in the worldwide market segment share for sync. So these are all very mission critical applications that require high performance. There's a level of security required also. And in fact, one that I thought was particularly interesting that I share. Anybody have any idea what this is? Shout it out. Man, I had no idea when I saw this originally. I'm embarrassed. This is Curiosity. It's the Mars rover. That's exactly right. And Microsemi is very privileged to be playing a role in a lot of the foundational subsystems in the Mars rover also. There's nothing like the pressure of knowing that your devices need to know what they need to do years and years out in time after they ship, and they need to open up with precision. So this is a fantastic example too. The last one Anybody want to guess what this guy has to do with Microsemi? Who is it? Dick Cheney. Yeah, Vice President Dick Cheney. He actually has had an unfortunate bout of heart-related problems, and we actually have a series of technologies that have actually been embedded into a device that was installed into his body, an implantable defibrillator, many, many years ago. So if anybody asks about Microsemi inside, we didn't trademark that. I just thought I'd show an example of how it might be true. So the tenets that survive all of this and surround all of this from a Microsemi perspective is performance, reliability, security, and power. And these are the exact same things that we, as a former group of PMCers and now Microsemi employees, actually embraced on a daily basis. It was a fantastic merging of the two groups together, and the thing that we brought to the table was access into storage. So that's enough about the history of the company. I'd like to go ahead and jump into the subject of our talk, which is, we've titled it the NVMe Inflection Point. Now, if you've studied PC history, or even had a role in the technology world, as pretty much everybody in this room has, you may have familiarity with Andy Grove. A phenomenal leader, took the helm of Intel Corporation and drove it into amazing growth. And he was kind enough to donate a lot of his learnings back to us as a society in the form of teaching. And one of the points that he talked about was this notion of a strategic inflection point. This inflection point is essentially a concept where in the evolution of a business, you hit this window of time where something disruptive has occurred, and you have a choice. You can act in the direction of addressing the disruption, or you can keep marching down the path that you're on, and you run the risk of a decline in your business. We believe that there's actually an inflection point in place in our industry now. And the people in this room have largely created a tremendous amount of disruption just by the very nature of what we're here to talk about, which is non-volatile memory being installed into storage systems and servers. That's created a ripple effect through the entire industry. And one of the sub-themes we submit to you is that NVMe is actually sitting right on that bubble where there's been a good amount of momentum that's in place, and now we're poised to see a tremendous amount of growth come with the industry. So that's what the balance of the talk is about. I'm going to spend a few minutes talking about the front half of this evolution and our observations of how we got to where we are, and then I'll spend a little bit of time talking about the back half and what we see in future for growth. So let's jump in. If you wind the clock back to 2012, 2010, somewhere in that window, there was this notion of leveraging the PCIe interface that existed in systems as a very low latency, high bandwidth interconnect that you could leverage for attaching solid state drive into a system. And in fact, one of the earliest pioneers was Fusion IO. There were others, but that was the one that definitely got quite a bit of interest and play. In that window of time, there was really very few players that had the ability to build these products. The market hadn't quite matured, but it was really, really clear that there was an opportunity. If we created standards as an industry, we could leverage this and actually add value into platforms moving forward. And so that's what we did. This first slide is a slide that we presented on this stage in 2014 at the Flash Memory Summit. There's two slides here. The one on the left was a foundational argument that says we've kind of seen this dynamic before in an industry where there's an opportunity to take a potentially large market and apply standards to it in order to achieve volume economics. And we identified three areas. One was on the protocol side. We created the NVMe, or the NVM Express standards work in concert with several of the people sitting in the room here. We also worked very hard as an industry to establish form factor standards. So we created the SSD form factor working group. And then we also looked at, and we continue to evolve forward on all of these, but the software API infrastructure through SNIA to look at ways for how could you harmonize APIs into this type of media and make it easier for people to build applications on top of. The second thing that we talked about was this notion of software-defined flash, where opportunities existed for people to actually construct PCIe-attached solutions with non-volatile memory on it and to create an ecosystem around it where you could buy controllers from merchant controller suppliers, you could buy NAND from the NAND suppliers, and you could have firmware be a differentiating piece that was put in place for the industry. Now, the good news is, actually, we've seen quite a bit of progress across all of these, and I'm going to talk about them throughout the balance of the talk. But I thought I'd show just a couple of proof points of this in flight, and specifically on the software-defined flash side. EMC announced an array called the D5. It's from their DSSD product line. And Tom's IT Pro actually did a teardown of this platform. It is an amazing, bar none platform in terms of the performance that it delivers and what they were able to achieve. What they did is they actually took a merchant controller. I'm not sure who that was. They took a merchant controller and they integrated it into a highly, highly dense form factor that they installed into a system, a PCIe-based system, to deliver unprecedented performance. The quote on this page is actually the thing, though, that I wanted to highlight. This notion of having controllers that are compatible with numerous types of NAND, allowing for choice, allowing for distribution of technology and building different types of SSDs, was actually foundational to how they selected what they were going to build. This option to actually go innovate using software and firmware on top of a controller with the ability to mix and match media types. Another example was actually announced here by our friends at Radeon. The RMS 235 is a drive that was built on a merchant controller, leveraging 12 terabytes of NAND, 12 gigabytes of DRAM, and then intelligent software to mix and match how you could actually accelerate given applications and given workloads. And then another one that you can see today in our booth, we actually market and promote, was built very similarly. So we took a merchant controller, we wrapped firmware and DRAM into a solution that's PCIe attached, and we can accelerate workloads using technology just like the prior two that you've seen before. So we see many examples of the software-defined flash materializing, and it's not just materializing in these few high-end applications. We now see the industry moving into a mode where they're trying to figure out how to do it more broadly and more cost-effectively. The other piece that I'll add as a status update is that we see designs being built on top of these controllers and a large, large number of SKUs being delivered and proliferated across all of the different types of SSDs. There's enterprise NVMe SSDs, there's hyperscale SSDs, and we also see SSDs being built for all flash arrays. You can see a whole host of them listed up here. The good news is that there's a ton of innovation that's going on in this space. There's different form factors. You've got add-in card, you got 2.5-inch. We actually saw discussions around M.2. We're currently involved in M.2 activities also. And then from our own perspective, what we've seen is an interest to develop around multiple types of NAND. That's fantastic. We're actually at the point where we've got more than 100 SKUs in development on flash tech-based products. And to us, that's actually a good sign that the market is picking up, as I mentioned, crawling up that curve, that inflection point curve. The last piece of update on this particular topic is that we've actually introduced the second generation performance PCIe SSD controller. We have a demo in the NVMe showcase that if you have the opportunity, please stop by and see. This product features LDPC infrastructure and performance that's enabling upwards of 1 million IOPS in SSDs on the performance segment of that market. So that was 14 and proof points supporting 14. What do we say in 15? In 15, we said, all right, there's this kind of common theme that we observed in the SAS and SATA world where as solid-state drives provided by us in the room in the industry get injected into storage systems, if those storage systems aren't built to take advantage of the performance, you create a bottleneck. And what we saw happen was a series of system changes that were made in our customer base and also in platform enablement. PCIe Gen 3 came along, higher port count expanders with low latency features embedded in them, and controllers to talk to those things being built to support larger and larger amounts of I/O traffic because NAND was put into that system. And what we posited was that the SAS and SATA infrastructure was going to become foundational as a capacity tier. If you wanted a substantial amount of storage to be placed into a given system, you would use SAS and SATA, but we saw this emergent tier based on PCIe. And what we showed was, on the far right of this graph, as you installed PCIe SSDs, we expected that you would see this ripple through of impact on system architectures, just like you did in SAS and SATA. And what that meant was that you were going to need an intelligent PCIe switch, something that could actually aggregate multiple PCIe SSDs with no compromises, that was highly integrated and capable. And we actually introduced a product last year in 2015, branded SwitchTech, the PSX for storage, a storage switch. And I actually hadn't anticipated when we showed this slide last year that I'd be standing up on stage again to have a conversation with the same audience, and we would have an example of somebody building a JBOF, just a bunch of flash, the way that it has been built across several examples. And I wanted to share a few of those with you today. Now, on this same stage yesterday, we had Vijay Rao from Facebook come up, and he described as one of the key pillars and tenets of their future direction this desire to aggregate SSDs, specifically NVMe SSDs. I think NVMe was used about 35 times in his speech. Aggregate NVMe SSDs into an array, a JBOF. And essentially what they've built with Lightning is a JBOF. And I'd invite you, if you have the opportunity, to come to our booth. You can actually see an example of Lightning built on top of the PSX devices that I referred to a few minutes ago, up and functioning. And what we've essentially done is we built a baseline platform that allows for connectivity, has hot plug support, but then we're also demonstrating how you can actually drive partition in a given array. One of the key features that you can implement on top of this infrastructure. Now, when we started down this path, one of the goals that we had set out was to say, how can we make this JBOD, the experience of it, look like what we experience with JBODs? Take a JBOF using the JBOD use case. And I was astounded when I read Chris Peterson's blog to actually see the quote at the bottom, which maybe it wasn't an accident, I don't know, but we want the NVMe JBOF to behave like a SAS JBOD. They've achieved that. This is actually a graphical depiction from the system. It might be a little bit difficult to see, but essentially what you see, and Vijay described this, was you now have a partition between compute and storage in these systems, where they're no longer intricately tied together. You can actually scale, based on a workload, the amount of compute and the amount of storage for the application that they need to service. And it's all enabled by leveraging PCIe as an interconnect and these JBOFs. Now, this isn't the only application example that's out there. The great thing about this that was also described was that the hardware design was donated to OCP, to Open Compute. And what that means is essentially people can come in and adopt, in any way they see fit, the platform. One of the earliest adopters that we've come across and worked with collaboratively is SK Telecom. SK Telecom has created a product called NV Array, and this is a picture of it. It features the SwitchTech PSX product, and in partnership with their friends at SK Hynix, they've actually delivered a family of NVMe SSDs also that are optimized for the use case. Now, the intent is for this array to actually be used captively within the SKT infrastructure across a host of workloads. But for us, it actually represents an example of how a blueprint design donated into a standards body can be proliferated broadly for multiple use cases. And we expect to see more of that. Now, the last example that I'll show is with our friends at Celestica. So within the storage system space, several people are exploring how they can integrate NVMe SSDs into their architecture, just like I described before. And what you'll see in our booth, if you happen to have the opportunity to come by, is that there's a project called Nebula 2U, a product that's a 24-bay NVMe JBOF. Along with it is a PCIe adapter, a host bus adapter, that interconnects into this. And the team has done just a wonderful job building a system that they white box and white label, and they'll make available to other individuals who are interested in investing in this space. It's another example of people taking standards, building base products, and then making them available for proliferation in the market. We expect to see a whole lot more of this over time. The final thing is in our engagements with customers around the PSX, the storage switch that I was describing before, the SwitchTech storage switch, we kept seeing this common theme from our customer base saying, hey, look, storage switch is great. We like it. We want to use it in our JBOF designs. But we like the features of it, the reliability features that are inside it, the integration, the low power. But we really have a fan-out use case, a use case that doesn't necessarily depend on some of the enclosure features that you've put into the PSX. And so what we did is we've actually developed a set of products particularly for this use case, and that's the fan-out family, the SwitchTech PFX. And this was announced last week. You can also see demonstrations of this out on the floor if you have an opportunity to check it out. So that brings us to kind of the center point of the inflection. Now, when we look at what it's going to take to bend the curve, to take that inflection point and get us into a position where we can actually start shooting up the curve and increasing volume over time, there's really three key things that we think are required. Now, the first one is broadly adopted standards. I think I've kind of beat that one to death. Having standards in place allows for interoperability. It allows for us as an industry to develop multiple types of products, and proprietary just simply doesn't cut it when you want to grow a big, big value proposition in the market. The second thing is cost-effective NVMe SSDs. If you go back and look at time, and I'll show you in just a little bit, the price of these SSDs had historically been prohibitive, but we actually see that becoming less of an issue moving forward. And then the last is we have to have systems infrastructure in place that allows for these products to actually be put and installed into systems in a simple way so that we can ramp. Now let's talk about the standard side, the broadly adopted standards. This organization has done just a wonderful job, I think, of getting the industry together, identifying a problem that they wanted to solve, and then tackling some of the best and brightest in the industry to kickstart it and opening it up for everybody to get engaged. And 2 years ago, when I showed that original slide with standards as a very important part of this and NVMe, we were actually at about 60 members in the working group. And the team's done a great job. They've almost doubled in size to get upwards of 115 to 120 members. There's a whole governing body in place, and there's 12 company board of directors. We're actually very privileged to be part of the crew that's helped define the standard and as a member of the BOD. But you can see that the individuals that are contributing here are among the industry leaders, and the teams of people that are supporting them within the infrastructure, exact same thing. So there's a ton of momentum that exists. But our work isn't done. So NVMe is a baseline specification. We can call that done. It's written, you can download it, you can actually find products. But there are enhancements that need to be delivered on top of it. One that we find particularly interesting is SRIOV. It's a single root I/O virtualization. Now what SRIOV enables is in that JBOF model that I showed you before, you can actually have a multi-host environment and you can start sharing those resources across hosts. Now, this is something that many people have tried to do proprietarily before. It hasn't been cracked in a standards way, in a material standards way. And we actually think that as an industry, we've got enough infrastructure in place to do it. And in fact, there's a demo that our team has put together in the Microsemi booth that you can see a little bit later today. If you have the time to stop by, tell them that Derek sent you. They'll love that. Where they actually show exactly what I just described. They have an SRIOV endpoint set up in a multi-host environment, and they can essentially share this SRIOV endpoint across multiple hosts across a network. The second piece is enclosure management. So I showed a JBOF, several instances of it, but there's still work to be done to address how that enclosure gets managed in a standardized way, in such a way that we can get enclosures from different places and talk to them in a uniform manner. This is cleanup work. Housekeeping, I think, was one of the words that somebody used to describe. It's in flight. There's a group that's targeted at it right now, but we just need to make sure that we push this over the edge so we can bend that curve, as we were talking about before. The last is NVMe over fabrics. Now, this is actually a hotbed of innovation and discussion here at the show in particular because of where we are. So we have a standard, we have a spec that's been put in place. We've got a lot of people that are innovating and building products. There's a long way to go to get interoperability in place, as well as to solve a lot of the software infrastructure work that needs to be applied in order to have fabrics functioning. We've seen fiber channel as one mechanism that's being used. You see NVMe over fiber channel. There's also NVMe over Ethernet that's in flight today. You see several examples of that. There's a ton of work that still needs to be done, but we're super excited because this is yet another opportunity to make easy how you can install these arrays of NVMe SSDs into an infrastructure over a fabric. So cost. I mentioned cost-effective SSDs as one of the key pieces to bend the curve. Well, this curve is actually, we want to bend it the opposite direction. But this is actually fantastic progress. We don't want to bend this up. We want to continue to see a decline. This is data from IDC. Jeff Janukowicz, if you haven't met him, produces this work on behalf of IDC. And this is his view, or their view, of the PCIe SSD decline on a dollars per gigabyte basis. Now, what you can see is almost, I mean, it's a phenomenal drop from a little north of $4 a gig in 2013 out to what equates to tens of cents on the far right edge in 2020. But that's a greater than 90% decrease over the horizon. Now, this is what will give us the opportunity to continue to grow NVMe SSD proliferation in the market, and it needs to continue. The other thing that I'll highlight on this is that it already is. In some cases, we see examples of large volume purchases taking place that are pulling that curve down even further, which is just only going to create further growth. Now, as part of this, as the dollars per gig drop, We also see a broader and broader number of swim lanes occupied with NVMe SSDs. And we see a great opportunity in the mainstream. And as a result, what we did is we created a product. It's called the NVMe 2008 and 2004. And this is an optimized solution for all of the mainstream PCIe SSD spaces. There's an 8-channel, 8 flash channel variant that's designed for the U.2 form factor, more optimized, and then a 4-channel that's designed for the M.2 space. And if you have some time again, maybe this is a common theme, please stop by our booth and check it out. Ask a few questions of the team. They're very proud of the demonstration that they have in place. All right, the last piece is systems infrastructure. Now, I hope after several of the slides that I've shown and also what you've seen here at the event, you believe that there's a large, large amount of momentum that's in place. We now have NVMe SSDs. We beat that one to death. Servers with U.2 enabled drive bays is something that we've been waiting on for quite a while. And there's been early signs of this. It's maybe 2014, 2015. The next wave of servers that come out next year are going to have broad proliferation of these U.2 enabled drive bays, which is going to allow an NVMe SSD to be placed inside that server with no issues from a hot plug or otherwise standpoint. JBOFs I talked about a little while ago. And on the coming soon list of items, there's really kind of 2 buckets that we see. One is RAID solutions. There's a definitive industry interest in having RAID being applied to NVMe SSDs. And it seems that software RAID is one option, maybe not so much loved, but hardware RAID is yet another. The other piece is NVMe over Fabrics, as we talked about just a minute ago. Getting solutions deployed that are interoperable, that allow for people to deploy these arrays of NVMe SSDs in a fashion across either Ethernet, fiber channel, or even direct attach and PCIe is only going to increase the amount of uptake that we see. So we actually think a lot of the pieces are in place in order to drive this. The coming soon items we need to keep working on. The standards we need to keep pressing on. But as an industry, the momentum is behind us. We actually are very, very excited about where this market is heading. And we actually look at it like we are just getting started. If you look at where we started with what was PCIe but now is NVMe SSDs, this is a graphic, again, from IDC of data showing where we're ending about 500,000 units in 2015. But if you look at that forecast moving forward, what you can see is it actually shows a very healthy growth to, on the outer edge, almost 15 million units in 2020. So even if it's a good portion of this, we've got the growth that we're looking forward to. So as a final comment, we do believe that although we're sitting at the base of that inflection point, we see the future looking very bright and a ton of opportunity for us as an organization, as a community, to go drive NVMe into the market in an even bigger way. That's all I have. Thank you very much for your time and attention. I really appreciate it. And please stop by our booth if you have the opportunity to do so. We're in booth 213. Thank you.